See, all of you clear know that topic hybridization. We studied the hybridization up to sp3. Like that you can extend, you can practice. Next one is P3d hybridization. For sp3d hybridization, I am taking the molecule is PCl5, ground statum, excited statum, and hybridization you can mark it. 5 orbitals are there, so sp3d hybridization you are getting. And come to the geometry of molecule. 3 PCl bonds are on the plane, making an equilateral triangle, and one Cl above the plane and other Cl below the plane. 5 bond pairs we can arrange it to maximum distance apart. So this will be the geometry or shape of the molecule. What is the shape or geometry? Is trigonal bipyramid. So on the plane it will make an angle 120 degree and perpendicular bond angle is 90 degree. So 2 bond angles are there in PCl5, 90 degree and 120 degree. And in PCl5 all the PCl bonds are same? No. So PCl5 on heating, the product you are getting is PCl3 plus Cl2. If all the PCl bonds are same, directly you will be getting phosphorus and chlorine. But instead of that you are getting PCl3 and Cl2. That means 2 PCl bond having less bond energy, or 2 PCl bond having one strength and other 3 PCl having another strength. Here the axial bond, 2 are axial and 3 are equatorial. The axial bond suffer more repulsion than that of equatorial bond. Axial bond suffer more repulsion than that of equatorial bond. That is why in PCl5 all the PCl bonds are not same. PCl5. Actually this is a structure that exists in gaseous state, gaseous phase. But in solid phase, PCl5, gaseous state and liquid state, PCl5 is existing like this. But in solid phase, PCl5 exists as a complex ion, PCl4 plus and PCl6 minus. This way PCl5 exists in which state? Solid state. And the anion is tetrahedral. Sorry, the cation is tetrahedral and the anion is octahedral in shape. Tetrahedral and octahedral. In solid state, that is the way PCl5 exists. Clear now? PCl5 sp3d. Then come to sp3d2, which is the molecule already studied now, SF6 sp3d2. There is no lone pair, 6 bond pairs are there. When we are arranging in maximum distance apart, the geometry of the molecule is octahedral. And what will be the bond angle? 90 degree. Clear now? So this is a common hybridization we studied. And next we can consider 2 central atom also. 2 central atom. 2 central atom means first one I am taking ethane, or I am taking ethene, CH2 double bond, CH2, CH triple bond, CH. 2 central atom with a single bond, double bond, triple bond. Now we already studied CH4 methane, ground state, excited state and all. So here carbon, which hybridization is P3. This carbon also is P3 hybridization. 4 new orbital there we are getting. That 4 new orbital overlap each other. We are getting 4 sp3 hybridized orbital having identical shape and equal energy. This is carbon-carbon bond and these 3 will overlap with the hydrogen atom. So each carbon is sp3 tetrahedral, bond angle 109 degree, 28 minute or 109.5 degree. Then come to ethene. Ethene double bond. When an orbital overlap with another orbital, we are getting covalent bond, mutual sharing. Actually, as a result of this sharing, there are 2 types of covalent bond. What are the 2 types of covalent bond we studied? What are the 2 types of covalent bond? Yes, sigma bond and pi bond. Sigma bond is formed by axial overlapping of atomic orbital, and pi bond is formed by lateral overlapping of atomic orbital. Is it clear now? You already studied sigma bond and pi bond. Which bond is strong bond? sigma bond. Okay, because extension of overlapping is maximum. 2p orbital, 2p orbital end to end. This one we are considering as a nucleus. So this overlapping will be maximum extension, it is possible. So this bond is which bond? Sigma bond. So it is more stable. But in the case of pi bond, lateral or sidewise, here the extension will be minimum. By because this is nucleus, this repulsion will be there. So the extension of overlapping is minimum. So this bond is weak bond. Sigma bond is strong bond. In a covalent molecule, the first bond formed between any atom is always which bond? Sigma bond. After the formation of sigma bond only, which one will form? Pi bond. That is, in the case of multiple bond, one is sigma, remaining all are pi bond. How we are getting pi bond? By the lateral overlapping of atomic orbital. So, in any molecule, pi bond is there, that much of p orbital we have to leave it from hybridization. Here one sigma bond, one pi bond. The pi bond will not take part in hybridization. That much p orbital we have to leave it from hybridization. So in the excited state of carbon, 2s, 2px1, 2py1, 2pz1. From that one p orbital we have to leave it from hybridization. So the hybridization is which hybridization? sp2. Remaining one p orbital overlap sidewise, we will be getting ethene molecule. So how to represent ethene molecule? So here will be hybridized orbital, and next carbon atom, the hybridized orbital will overlap, and p orbital unhybridized. So this will overlap with the hydrogen. This is carbon-carbon sigma bond. Then these unhybridized p orbital overlap sidewise, and we will be getting which bond? Pi bond. So how many sigma and pi bonds are there in ethene or ethylene molecule? 1, 2, 3, 4, 5 sigma bond and 1 pi bond. How many pi bonds are there in the molecule? That much of p orbital we have to leave it from hybridization. That is the way we are noting the hybridization. And finally, any double bond is there. One is sigma bond and other is pi bond. And triple bond, one is sigma bond and other two are pi bond. So 2 p orbital we have to leave it from hybridization. So what hybridization will be here? sp hybridization. One s orbital and one p orbital. So acetylene is linear in shape. Is it clear now? Two central atom. Both the element hybridization we can note it. In the case of multiple bond, only one is sigma bond and others are pi bond. Sigma and pi bond, which is strong bond? Sigma bond. In a molecule, the first bond formed is always sigma bond, then only pi bond will form. Pi bond is formed when a sigma bond is already exist. Suppose I am giving you one molecule, CH2, double bond CH, CH2, C triple bond C, CH3. Can you identify the hybridization of each carbon atom in this molecule? First carbon, here on double bond will be there. So which hybridization? sp2. Here also double bond, sp2. Here sp3. Here sp. Here sp. Then sp3. This way we can identify double bond sp2, triple bond sp. That way we can identify the hybridization. Now, suppose you are getting a molecule, any one molecule you are getting. In that molecule, directly you have to identify hybridization. How to identify hybridization there in molecule? There are different methods for the identification of hybridization. One is the simple method based on number of bond pairs and lone pairs of electrons. Suppose I am having one molecule, methane, CH4. How many bond pair? 4. How many lone pair? 0. So how many total pairs of electrons are? 4. That means 4 orbitals are involved in hybridization. So the hybridization is 1, sp3. Water, H2O. How many bond pair? 4. How many lone pair? Sorry, bond pair? 2. How many lone pair? 2. So total how many pairs of electrons are there? 4. So what is the hybridization? sp3. Now SF4. How many bond pair? 4. How many lone pair? Sulfur valence shell 6 electron, 4 bond pair and 1 lone pair. So what is the total orbital? 5. So which is the hybridization? sp3d. Like that, based on number of bond pairs and lone pairs there in the central atom, we can identify the hybridization. That is the first method. And the second one, the first method is not applicable in the case of all ionic species and all. Sometimes it may be difficult to identify the lone pairs and bond pairs in ionic species because you must thorough the valence electron and all. Now we can apply the second method for identification hybridization is we can use one formula. It is half into V plus M minus C plus A. This is a formula we are using for the identification of hybridization, whether it is an ionic species or non-ionic. It is very important formula. Any species you can identify the hybridization. C means V. What is V? Valence electron. Valence electrons of the central atom. Valence electron of the central atom. What is M? Number of monovalent atom. Number of monovalent atom. And what is C? Charge of cation. Charge of cation. And what is A? A is charge of anion. So based on this formula, we can calculate the hybridization of any molecule, whatever it is, whether it is an ionic species or a non-ionic species, we can calculate the hybridization by using this formula. But you must thorough what? You must thorough valence electron. Valence electron is based on group number. When an element is getting, you try to understand in which group. You know group number, then you can identify the valence electron. Then M is number of monovalent atom. Monovalent atom is in the case of monovalent atom, normally hydrogen and halogens are only monovalent. Hydrogen and halogen. In the molecule, any number of hydrogen atom is there, that you have to consider. Any number of halogen is there, that also you have to consider. No other elements are there, so we are not considering the number of monovalent atom. Clear no? Now we can take it. First example I am taking in one molecule. See, Br3. Boron trifluoride. It is an interhalogen compound. What is the central atom? Bromine. Br3. Bromine. What is the valence electron? Halogen. No needed to count the atomic number and all halogen valence shell contains 7 electron. So valence shell 7 electron. Half into valence electron of the central atom 7 plus monovalent. Fluorine is the combined atom. So fluorine is monovalent or any other valency. Monovalent. So 7 plus 3. Cation is not here, anion is not here. So 10 by 2, 5. So the hybridization is sp3d. 2. Any molecule SF4 half into valence electron of the central atom 6 plus 4. Same sp3d. Okay. Are you copying now? Yes, next molecule. One simple molecule I am writing, carbon dioxide. You just identify what is hybridization in carbon dioxide molecule. Half into valence electron of the central atom 4. Any monovalent atom here? No. Option is divalent. So 4 by 2 is equal to 2. So which is the hybridization? sp hybridization. Okay, like that you can write it. Any molecule you practice. Now I am taking ionic species NH4 plus. Ammonium ion NH4 plus. What is it? Half into valence electron of the central atom 5 plus number of monovalent atom 4. Is it a cation or anion? It is a cation, positive charge cation. So what is the magnitude of 1? So minus 1. 8 by 2, 4. So 4 orbital is P3 hybridization. Are you noted the formula? No, it is very important. By noting using this formula, any species you can identify the hybridization. Cation. Then SO4 2 minus. Valence electron of the central atom 6. Any monovalent atom? No, 0. Cation, it is an anion. What is the charge of anion? 2. See, in the A and C, the magnitude only we are substituting, not consider the sign. Only magnitude here we have to substitute. So 4 again sp3. I am giving one species I3 minus. It is an ionic pair. What is the hybridization of I3 minus? You calculate the hybridization. 3 iodine. 1 iodine you have to consider as a central atom, and the other 2 iodine you have to consider as the combined atom. Half into V, valence electron of the central atom 7 plus number of monovalent atom 2. So cation or anion? Anion minus charges, so plus 1. 1 iodine central atom, valence shell 7. Other 2 combined atom, both are monovalent. Number of monovalent atom 2. It is an anion, so plus A on. A is the magnitude of anion 1. So 10 by 2 5. So that is the way you can identify the hybridization of any one species. This formula you have to follow. You have to thorough this formula and follow your own way. You can write many molecules and you have to practice what is the hybridization. These two based on bond pair and lone pair and this formula. Other method also they are not to follow all the method, any one method. The most convenient method is this formula. Other method we can use it based on the valence electron of the all atom. All atom in the molecule, all atom valence electron you have to consider. Valence electron divided by 8. What is the answer you are getting? If any remainder is there, the remainder again divided with 2, you will be getting the hybridization. That way also we can find out. Total valence electron by 2. Whole molecule you have to consider. Whole molecule all valence electron by 8. 8 is completely divisible, the number will be the hybridization. Any remainder is there, then again that remainder you have to divide it with 2. Then total, first division and second division, total is the hybridized orbit. Clear now? It is very important when you are getting a molecule, identify the hybridization by using that formula. Now, a covalent bond is formed by mutual sharing of electron between atom, but these electrons are existing in various orbitals. So during the covalent bond formation, orbitals are intermixing, and as a result of intermixing of orbitals, there we are getting 2 types of covalent bond, sigma bond and pi bond. That difference we noted. Now, as a result of this overlapping, we are getting one molecules. So in the molecule also, these electrons are existing in various orbitals. Molecule also electrons are existing there in various orbitals. That orbitals are called molecular orbital. Atomic orbital overlap, we will be getting one molecular orbital. When atomic orbital overlap means, actually in the orbital what will be existing? Electrons. Electrons are not existing. So electrons intermix ചെയ്യുന്നു. അങ്ങനെയാണ് നമുക്ക് molecules കിട്ടുന്നത്. Atoms തമ്മിൽ intermix ചെയ്യുന്നു. Atomത്തിൽ intermix ചെയ്യുന്നത് actually electron. But electrons are existing in orbital. അപ്പോൾ orbital ആണ് intermix ചെയ്യുന്നത്. അപ്പോൾ നമുക്ക് പുതിയ orbitals കിട്ടും. Moleculesനകത്ത് electrons തന്നെയാണുള്ളത്. ആ electrons exist ചെയ്യുന്ന orbitals നമ്മൾ വിളിക്കുന്ന പേര് molecular orbital. How we are getting this molecular orbital? By the combination of atomic orbital. രണ്ട് atomic orbital intermix ചെയ്യുമ്പോൾ we will be getting molecular orbital. ഇനി molecular orbital ഫോം ചെയ്യുന്ന പ്രധാനമായിട്ടും രണ്ട് തരത്തിലാണ്. ഒന്ന്, atomic orbital intermix ചെയ്യുമ്പോൾ ഇലക്ട്രോണിന്റെ നേച്ചർ നമുക്കറിയാം. ഇലക്ട്രോൺ ഷോ ഡുവൽ ക്യാരക്ടർ, പാർട്ടിക്കിൾ നേച്ചർ, വേവ് നേച്ചർ. വേവിന്റെ പ്രൊപ്പഗേഷൻ എല്ലാം നിങ്ങൾ പഠിച്ചിട്ടുണ്ട്. വേവ് നമ്പർ, വേവ് ലെങ്ത്, എവരിതിങ്. ഓക്കെ, സോ വേവ് ഇന്റർമിക്സ് ചെയ്യാം. ഇലക്ട്രോണുകൾ ഇന്റർമിക്സ് ചെയ്യുന്ന വെച്ചാൽ വേവ്സ് തങ്ങൾ ഇന്റർമിക്സ് ചെയ്യുന്നു. ഇന്റർമിക്സ് ചെയ്യുമ്പോൾ 2 പോസിബിലിറ്റി ഉണ്ട്. their resultant wave കമ്പൈൻ ചെയ്തു വരുന്നതുകൊണ്ട് ക്യാൻസൽ ചെയ്തു പോകുന്നുണ്ട്. ഫിസിക്സ് നിങ്ങൾ പഠിച്ചു ഇന്റർഫറൻസ്. സെയിം വേ ഹിയർ മോളിക്കുലർ ഓർബിറ്റൽസ് ഫോം ചെയ്യുമ്പോൾ അറ്റോമിക് ഓർബിറ്റൽ കമ്പൈൻ ചെയ്യുന്നു. ദാറ്റ് മീൻസ് their wave functions are joining or intermixing. As a result, 2 types of molecular orbital we are getting. Okay, one is by addition, wave function add up, addition of atomic orbital, and other is by subtraction of atomic orbital. We used the term addition and subtraction actually based on the wave function. Wave function add up and wave function cancelled, that is subtraction. So the molecular orbital formed by addition of atomic orbital is called bonding molecular orbital, and subtraction of atomic orbital is called anti-bonding molecular orbital. Okay, bonding and anti-bonding. Bonding molecular orbital, if it is sigma, and anti-bonding is represented by one star symbol, sigma star. Which one having more energy? Anti-bonding. Okay, so atomic orbital overlap. Suppose my atomic orbital is one oneness and other oneness are intermixing. There I am getting how many atomic orbitals are intermixing? Same number of molecular orbital we are getting. One is sigma oneness and other is sigma star oneness. Same way, 2 2s orbitals are intermixing, sigma 2s and sigma star 2s. Then in the case of p orbital, 2px, 2py, 2pz intermix with another p orbital, which are the molecular orbital formed by the combination of 2p orbital. See, p orbital, px, py, pz, 3 orbitals are there. First we are filling 1 by 1 electron there. Suppose in the case of p orbital, px and py, that is on the plane, perpendicular to the plane, and z orbital is projected towards outside. X and y on the plane, z is projected towards outside. Like that, another p orbital. X and y on the plane, perpendicular to each other, z projected towards outside, that also perpendicular. Such 2 p orbitals are approaching. Which one will overlap first? Pz orbital. So pz make which bond? Sigma bond. Other 2 p orbital will make which bond? Pi bond. P orbital overlap ചെയ്യുമ്പോൾ ആദ്യം ഓവർലാപ്പ് ചെയ്യുന്നത് ഏത് ബോണ്ടാ? സിഗ്മ ബോണ്ട്. പിന്നീട് ഫോം ചെയ്യുന്ന 2 പൈ ബോണ്ട്. അപ്പം പി ഇസഡ് ആണ് ഏത് ബോണ്ട് ഫോം ചെയ്യിക്കുന്നത്? സിഗ്മ ബോണ്ട്. Because z is overlapping first. So the orbitals are sigma 2pz and sigma star 2pz. Other 2 are pi bond. Pi 2px, pi 2py, they are anti-bonding. Pi star 2px, pi star 2py. These two having same energy. These are the molecular orbital formed by the combination of atomic orbital. Now we have to arrange this molecular orbital in the increasing order of their energy level for filling electrons. Atomic orbital 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, that you filled on the basis of energy level. When you are filling electron, you follow, that is Hund's root, Pauli's exclusion principle and Aufbau principle. Same way in molecular orbitals also, when you are filling electron, they are in molecular orbital, all the rules and regulations here also you have to follow up. So in the case of p orbital, see, initially we are filling 1 electron each there in p orbital, x, y, z, that order we can keep it. X il 1, y il 1, z il 1 ആയിട്ടാണ് നമ്മൾ കൊടുക്കുന്നത്. അപ്പോൾ ഓരോ ഇലക്ട്രോൺ വരുമ്പോൾ നമ്മൾ x, y, z order keep ചെയ്യുന്നു. But when it starts sharing, that time which orbital only we have to write it first? Z orbital. So p orbital ഓരോ ഇലക്ട്രോൺ വരുന്നത് up to nitrogen, px1, py1, pz1, 7. Oxygen onwards it will start pairing. Pairing start ചെയ്യുമ്പോൾ ഏത് ഓർബിറ്റലാണ് ആദ്യം പെയർ ചെയ്യുന്നത്? Z orbital. അപ്പോൾ Z ആണ് സ്റ്റാർട്ട്. So MO configuration, when you are writing on the basis of their energy level, sigma 1s and sigma star 1s, then sigma 2s and sigma star 2s, then pi 2px is equal to pi 2py, then sigma 2pz. Next one, pi star 2px is equal to pi star 2py, and finally sigma star 2pz. This is MO configuration up to which element? Up to nitrogen, because up to nitrogen p orbital not sharing. Then oxygen onwards, O2 onwards, what will happen there? Sharing of p orbital will start. Okay, so the order will be oxygen onwards, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then next one, sigma 2p z is pairing first. Then pi 2px is equal to pi 2py. Then pi star 2px is equal to pi star 2py. And finally sigma star 2pz. So very important MO configuration up to nitrogen and then oxygen. See, the purpose of this MO diagram, for what purpose we studied this MO diagram is for the calculation of bond order of a molecule. Bond order. What is the formula you studied for bond order? Yes, half into NB minus NA. For what purpose we are calculating bond order? From the bond order we are getting many concept regarding that particular molecule. If the from the bond order value we can predict the stability of molecule. Suppose you are getting 3 molecule, they are asking which is more stable. So when you are calculating bond order, which one has more bond order, that has more stable. And in the case of a simple diatomic molecule like a hydrogen, when you are calculating bond order, you are getting 1. In the case of simple diatomic molecule, the bond order value gives the number of bonds between the atoms. Bond order value നമ്മൾ calculate ചെയ്യുമ്പോൾ കിട്ടുന്ന വാല്യൂ ആ രണ്ട് ആറ്റങ്ങൾ തമ്മിൽ എത്ര കോവാലന്റ് ബോണ്ട് ഫോം ചെയ്യുന്നു. ഹൈഡ്രജൻ എത്ര കോവാലന്റ് ബോണ്ട് ഉള്ളത്? രണ്ട് ആറ്റം തമ്മിൽ 1. സോ ബോണ്ട് ഓർഡർ 1. ഓക്സിജൻ when you are calculating bond order 2 because O double bond O. Nitrogen when you are calculating bond order, it is answer 3 because N triple bond N. Bond order related to bond length and also bond energy or bond dissociation energy. As the bond order increases means the number of bonds is increasing. So the bond energy or bond dissociation energy also increases. Okay, so bond order is directly proportional to bond dissociation energy and bond order is inversely proportional to bond length. Bond order കൂടുന്നതനുസരിച്ച് bond length കുറയും. ആറ്റങ്ങൾ തമ്മിൽ കൂടുതൽ അടുത്തടുത്ത് വരിക, അവർ തമ്മിലുള്ള interaction കൂടുകയാണ് ചെയ്യുന്നത്. Okay, and NB and Na, all we are calculating on the basis of NB value and Na value. NB is always greater than that of Na, then the molecule is stable. NB value കൂടുന്തോറും species in the stability കൂടിക്കൊണ്ടേയിരിക്കും. And when you are arranging molecule there in the molecular orbital, any molecule there is unpaired electron, then the molecule become paramagnetic in nature. Unpaired electron is there. See, suppose you are getting the species like O2, O2 minus, O2 plus, O2 2 minus. They are asking among this species which one is diamagnetic. O2, when you are writing O2 how many electrons are there totally? 16. So ending is pi star 2px1 is equal to pi star 2p by 1. That is the ending for O2. Pi star 2px1 is equal to pi star 2p by 1. 16 electron when you are arranging in that MO configuration, this will be the ending of oxygen. Unpaired electron, so it is which nature? Paramagnetic. Then O2 minus means one more electron we have to add up. So what is the ending? Pi star 2px2 is equal to pi star 2p by here 1 only, 3 electron. So this also paramagnetic. Then O2 plus, we have to remove 1 electron from oxygen. So pi star 2px is equal to pi star 2p by x il matra or electron. So this also paramagnetic. Then O2 2 minus, O2 about 2 minus. So 2 minus means 2 electron it is getting. So the configuration become pi star 2px2 is equal to pi star 2p by 2. Both are paired. There is no unpaired electron, so it become diamagnetic. Then bond order increases, stability also increases, and bond length decreases and bond dissociation energy increases. Suppose based on the number of electrons, then bond order. Suppose the number of electron is 8. Bond order when you are calculating, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, like this you are getting. So when you are getting the bond order, it is 0. Bond order is 0 means that molecule does not exist. For example, when you are taking He2, I am just considering, you know, noble gases are not forming diatomic molecule. He2 total how many electrons are there? 4 electrons. Sigma 1s2, sigma star 1s2. When you are calculating bond order is, what is the value of bond order? 0. 0 means the molecule will not exist. So He2 will not exist. So 8 is 0. When you are calculating, number of electrons is 9, the value is 0.5. Number of electrons is 10, 1. Then 11, 1.5. Number of electron 12, it is 2. Then 13, 2.5. 14, 3. Then it will be decreasing. 15, it is again 2.5. 16, 2. 17, 1.5. 18, 1. 19, 0.5. 20, 3, then 2.5, 2, 1.5, 1.5, sir. Like that bond order directly you will be getting. Okay, so based on the table column we can calculate the bond order. So if you know the number of electrons in that particular species, directly you can write the bond order if you know the table column. So you have to by heart it based on the number of electron, what will be the bond order. As the bond order increases, stability of the molecule also increases. So we can compare the stability of different species by using its bond order value. Which one is more bond order? That is more stable. Okay. Suppose in the case of some ionic species, we will be getting same bond order value. We can take an example, He2, He2 plus, He2 minus. We just calculate the bond order He2, comma, He2 plus some, He2 minus. He2, what is the number of electron? 2. So sigma 1s2. He2 plus sigma 1s1. He2 plus 2 hydrogen, 2 electron, 1 electron loses, so remaining only 1 electron. And He2 minus, they getting 1 more electron, so 3 electron. So what will be the bond order of He2? He2 bond order 1. Here bond order 1 by 2, 0.5. He2 minus bond order 2 minus 1 by 2, 1 by 2 again 0.5. You just see He2 plus and He2 minus same bond order. So which is more stable? So on the basis of bond order we can predict both are same stability, but actually both are not having same stability. How we can identify that? You know, you just see the electron. In He2 plus 1 electron is in bonding molecular orbital, and He2 minus, the last electron is in which orbital? Anti-bonding molecular orbital. And same bond order, but the last electron is in anti-bonding molecular orbital. Anti-bonding molecular orbital possesses more energy, so less stable. So this He2 minus is less stable than that of He2 plus. Clear now? Because in He2 minus, the last electron is in anti-bonding molecular orbital. Here only in bonding molecular orbital. Bonding molecular orbital is more stable. So same bond order is there, then check the MO configuration. The electron is in anti-bonding, less stable. Clear now? Okay, many species like this you will be getting same bond order, but when you are writing the order of stability is, which is most stable, highest bond order value, hydrogen. Hydrogen is more stable, H2. And then H2 plus and H2 minus, which is more stable? Yes, H2 plus. Least stable is He2 minus. This is the correct order of stability of hydrogen and its ionic species. Okay, like that bond order is very important. Bond dissociation energy, bond length, like that we can arrange it. Clear now? These are the main topic or content included in the chapter. Now we can practice some questions, you know. Are you ready to write the question? Based on the content. Actually this chapter fully theoretical chapter only. Very simple topic and directly you can learn it. So based on the content, first you have to thorough the content and practice maximum number of questions. Practice more and more. Lot of time you are getting. Okay, you all are staying home. Correct, no? So full time you have to utilize. Take initiative. So direct contact not possible. So there are some limitations based on the condition. To overcome it, that is the main thing you have to learn it from education. How to overcome when you are facing a situation. How to overcome it. So stay home and practice maximum number of questions. So lot of time you are getting. One more month is there, so you can practice the maximum number of questions. Thorough the content. First you go through the content and write it, main points you note down, equations and everything, formulas and everything you have to write it. On a diary sheet you have to prepare, and again you have to revise it and you have to recollect it. If you are not getting that time itself, you have to study again and practice the questions. Okay, we can practice some questions now. Question number 1, write down. First question is, which of the following compound is planar and non-polar? Which of the following compound is planar, represented on a plane, planar and non-polar? It does not show polar character. The options given are XeOF4, XeOF4, SF4, XeF4 and CF4. We can represent on a plane and non-polar molecule is non-polar, not to show polar, or any polar strength is there that has to cancel. What is the first molecule? XeOF4. How the structure will be there? XeOF4, Xe, double bond O, double bond O, double bond O, double bond O. Can you represent on a plane? No, it is a non-polar, non-polar and non-planar. Non-polar, non-planar. Then SF4, 4 SF bond, 1 lone pair. 4 SF bond, 1 lone pair. What is the geometry of that molecule, or what is the shape of that molecule? Geometry based on 5 pair of electron, geometries was trigonal bipyramid. And what is the shape of the molecule? Seesaw. SF4 is seesaw. So it is polar, but it is non-planar. Why it is non-planar? Due to the presence of one, not non-planar, non-polar, due to the presence of one lone pair of electron. Next molecule is one XeF4. XeF4, 4 fluorine on the plane, making a square shape. 1 lone pair above, 1 lone pair below. So we can represent on a plane because square shape, square only shape. 1 lone pair above, 1 lone pair below. So what is the polar character? Mu value is 0. So third one is the correct option. And fourth one, what is in CF4? CF4 is any polar character is having? No, it is mu value is 0. All the dipole moment opposite direction, so they cancel each other. So first question is clear now. The correct option is the third one, XeF4, planar and non-polar. And the second question, correct set of species with zero dipole moment. Among the following molecule, which set is having zero dipole moment? The molecule given are CO2, CH4, CH2Cl2, COCl2. Carbon oxychloride last. CO2, CH4, CH2Cl2 and COCl2. Which of the set, given set? Options are first one 1 and 4, 1, 3 and 4. Third one 1, 2 and 3. Fourth one 3 and 4. Then CO2, what is the dipole moment value? 0. CH4, 0. CH2Cl2, Cl2 in opposite direction it will be acting 0. Calcium oxychloride not 0. C double bond O and Cl. Different atoms, so different bond strength. Polar value will be there in the case of COCl2. Remaining all are 0. So the correct option is 1, 2 and 3. Are you getting now? correct set of species with zero dipole moment is the question. These are the species given, these are the set. Third question, arrange the following ions in the order of decreasing XO bond length, where X is a central atom. Arrange the following species in the order of decreasing XO bond length, where X is a central atom. So all are oxygen. Oxygen is having an electronegativity 3.5, and the combined atom you have to check in. The electronegativity difference is more than the bond length is less. So based on the electronegativity difference we have to consider. Decreasing order of bond length, arrange them in the decreasing order of their bond length. Silicon, oxygen, see element you know, chlorine and oxygen, sulfur and oxygen, phosphorus and oxygen, silicon and oxygen. Chlorine, halogen, electronegative element is electronegativity value also nearly 3.5 around the value. Sulfur less than that to chlorine. Phosphorus less than that to sulfur. So silicon is a metalloid, so not a non-metal. So least electronegativity value will be there. Least electronegativity value will be there means bond order or bond length, decreasing XO bond length done. So electronegativity difference is more, so interaction is weak, so this is more bond length. And moving down the electronegativity, then phosphorus, sulfur, chlorine. Chlorine, oxygen electronegativity difference is least, so their bond is strong, bond length is less. So this is a decreasing order of their bond length that we can predict on the basis of difference in electronegativity between the atom. Oxygen is common, then silicon, phosphorus, sulfur, chlorine, that is the order of electronegativity. Silicon is a metalloid, then phosphorus a non-metal, sulfur, then electronegative, oxygen and sulfur, nitrogen and phosphorus are least electronegative, then chlorine. Then next question. So here the correct option is, second one is the correct option. Then next question, fourth one. Which one of the following sequence represents the increasing order of the polarizing power of the cationic species? Increasing order of polarizing power of cationic species. K plus, Ca2 plus, Mg2 plus, Be2 plus. Polarizing power of cationic species. Smaller the size, higher the charge. Smaller size and higher the charge, more will be the polarizing power. So smaller size, higher charge, that will be more polarizing power. Smaller size, which one? Beryllium, Be2 plus. Potassium, these are second group. Second group in a periodic table, left to right, atomic size decreases on. Okay, so the least one is B. B having 2 plus. Charge increases, polarizing power increases. Size decreases, polarizing power increases. So the least one is K plus, potassium large size. And then calcium, magnesium large size is calcium. Then magnesium. Then beryllium. Number of options are given. This is the correct option for polarizing power. Question is clear now. Which of the following sequence represents increasing order of polarizing power? This is the sequence. How we can write it? Smaller the size, greater the charge, more polarizing power. Next question, question number 5. The group having, among the following group, which one having trigonal planar structure? Group having trigonal planar structure. BF3, NF3 and CO3 2 minus. CO3 2 minus, NO3 minus, SO3. You just arrange it molecule NH3, SO3, CO3, lone pair and bond pair. You can arrange it molecule. Based on that one you can write it NCl3, BCl3 and SO3. These are the 4 options. And the question is the group having trigonal planar structure. Trigonal planar. BF3 is trigonal planar. NF3, one lone pair will be there, so it is not trigonal planar. This is okay. Then CO3 2 minus trigonal planar. NO3 minus trigonal planar. SO3 is double bond O, double bond O, double bond O, trigonal planar. So the second option is the correct option. Here NH3 not trigonal planar, pyramid. NCl3 not trigonal planar, lone pair will be there. Then question number 6. In the structure ClF3, the number of lone pair of electron on central atom chlorine is. Now down all of you, ClF3, we already noted ClF3, the central atom, they are asking only the central atom, how many lone pairs? How many lone pairs central atom? Chlorine, total electrons 7, 3 are involved in bonding, remaining 4 electrons, so 2 lone pair. Then, which of the following molecule include represents the order of hybridization? Which molecule is having the order of hybridization? sp2, sp2, sp, sp, sp3. Among the following, which one is this order? This is the last year NEET exam question. sp2, sp2, sp, sp, sp3. This order is keeping which one? See, without option also, what is the answer will be there? First 2 carbon atom, which bond will be there? Which bond? Double bond, sp2. Then sp, which bond will be there? Next 2 carbon, triple bond. And last single bond, CH3. Okay, so first 2 carbon, double bond, this arrangement. Then triple bond C. Then single bond CH3. Remaining valence hydrogen you can give it. This will be the correct option. Correct. Now from the option, this order you have to keep it. sp2, sp2, sp, sp, sp3. Are you following now? Next question. Which of the following pairs of compound is isoelectronic and isostructural? Isoelectronic means same number of electron, and isostructural, same structure. First option is TeI2 and XCF2. Second option IBr2 minus and XCF2. Third one IF3 and XCF2. And fourth one BeCl2 and XCF2. Isostructural and isoelectronic, same structure and same number of electron. Valence electron is just to check it. This is tellurium. Which group? 16th group. 6 electrons are there. Xc 8 electron. 8 2 are involved. So same isostructural will not come. Second one iodine. 7 electron, but iodine is getting an extra electron, Br2 minus. So iodine is possessing how many valence electron? 8. Then 2 are involved in bonding with the bromine. Same, xenon 8. 2 are involved in bonding with the fluorine. So these 2 are isostructural and isoelectronic. IF3 and XCF2. Here iodine 7 electron, here 8 electron. Beryllium, xenon, will not come. So second option is the correct option. Isostructural and isoelectronic we can identify on the basis of their valence electrons. Then which of the following species have highest bond order? Next question. Which one has highest bond order? Are you noting the question? Which one has highest bond order? Options are, one is Cn minus, then Cn plus, NO and Cn. Here how many electrons are there? 7, 6, 14 electron. Here, sorry, Cn plus, Cn minus, Cn plus. So here, nitrogen atomic number 7, carbon 6. 14. Here in 6 is 7. So 12. NO. Oxygen atomic number 8, 7. So 15. CN 7. So based on that one, bond order you write it. So which one has highest bond order? Cn minus. You noted atomic number 12, 14, 13, 15, what will be the bond order? So the correct option you are getting is Cn minus. 14 electron number, bond order will be 3. Next one. Decreasing order stability. There also O2, O2 minus, O2 plus, O2 2 minus. Decreasing order of stability. So what do you arrange them in the decreasing order of their stability? Arrange it. Decreasing order of stability. Stability means what you have to find out? Bond order. O2, what will be the bond order? 2. Then O2 minus 1.5. O2 plus 2.5. O2 2 minus 1. So bond order increases, stability also increases. Bond order decreases, stability decreases. So the order you can write it. Which one is least stable, most stable? O2 plus, then O2 plus greater than O2, then O2 minus, and least one is O2 2 minus. O2 plus greater than, O2 greater than, O2 minus greater than, O2 2 minus. This is the order of stability, decreasing order of stability. Correct now? Directly you can note it from the bond order value. Bond order how you are getting? From the number of electrons. Okay, next question. Which of the following species contain equal number of sigma and pi bonds? Which of the following species contain equal number of sigma bond and pi bond? Sigma bond and pi bond. First molecule XeO4. Note down the structure, from that you can write it. Cn twice, C triple bond N twice connected. CH2, Cn twice. And fourth one HCO3 minus. Carbonate radical, bicarbonate. Which one contain equal number of sigma bond and pi bond? XeO4, we already noted the structure. Xe, double bond O, 8 electron, double bond O, double bond O, double bond. From the structure it is clear. 4 sigma bond, 4 pi bond. Multiple bond, only sigma and other is pi. So this will be the correct answer, but this is linear structure. C triple bond N on. So 2 pi bond, 1 sigma bond 1. So total sigma bond, pi bond and sigma bond is not equal here. Same way, C triple bond and environment not equalize. Then HCO3 minus. CO3 minus is structure we studied. C double bond O, coordinate bond O, coordinate bond O. Sigma bond and pi bond is not same. So this is the molecule. First structure itself we are getting equal number of sigma bond 4, pi bond 4. Then next one you are getting, which of the following is paramagnetic? Which of the following is paramagnetic? So based on the electronic configuration, number of electron, you write the electronic MO configuration. O2 minus, Cn minus, NO plus and CO. O2 minus, how many electrons are there totally? 17 electrons. 17 electrons here. 14 electrons. Here. Oxygen 8, nitrogen 7. Again 14 electrons. Carbon monoxide. Among the following, which one is paramagnetic? Paramagnetic means unpaired electrons. Unpaired electron will be coming there in O2 minus only. 14 all are paired. Nitrogen configuration, diamagnetic. The next question, in which of the following molecule the central atom does not have sp3 hybridization? Which of the following the central atom is not in sp3 hybridization? Central atom is not in sp3. You apply that formula and find out the hybridization. NH4 plus. NH4 plus is which hybridization? sp3. Half into V plus M. Then CH4 we already studied sp3. Then SF4 sp3d. Then BF4 minus sp3. So the answer is SF4 minus, not in sp3 hybridization. Then next question, N2 and O2 are converted into N2 plus and O2 plus. N2 plus and O2 plus. Which of the following statement is wrong? Nitrogen and oxygen are converted into N2 plus and O2 plus. Nitrogen MO configuration you have to recollect, and O2 MO configuration you have to recollect. Then the option, first option they given is N2 plus, the NN bond is weakened. N2 plus the NN bond is weakened. Then in O2 plus, second option, in O2 plus OO bond order increases. O2 plus O2 changes to, what is the bond order of O2? 2. What is the bond order of O2 plus 2.5? So bond order increases. Then third option, in O2 plus paramagnetism decreases. In O2 plus paramagnetism decreases because O2 contain 2 unpaired electron, but O2 plus contain only 1 unpaired electron. So paramagnetism decreases. So first three options are correct. First one is in N2 plus the NN bond weakened. In N2 plus because N2 N triple bond N on N triple bond N. So that bond will be weakened. N2 plus bond order will decrease. So the first three options are correct. Then fourth option, N2 plus becomes diamagnetic. N2 plus is not diamagnetic, N2 plus is paramagnetic because 1 unpaired electron will be there. Fourth option given is N2 plus become diamagnetic. First option, are you noted all the options now? First option, in N2 plus, comma, the NN bond weakens. Second one, in O2 plus, the OO bond order increases. Third one, in O2 plus, paramagnetism decreases. Fourth one, N2 plus becomes diamagnetic. That is the wrong option. M2 plus also paramagnetic because 1 unpaired electron will be there. Like that, you have to practice more and more questions. Bond order related questions all are there based on hybridization. Same hybridization are there based on S character and P character. We can predict a bond order like that. Many concepts are there. You have to practice maximum number of questions. So these are the content you have to study there in the chapter chemical bonding and molecular structure. I hope all students understood the content clearly. So any doubt is there in the next class when you are attending the next class, that time you can ask the questions or you can directly type it and ask, or any way you can do it. So maximum number of questions you have to practice. That is the only options we can do it there. Now you are getting lot of time for practicing. I already mentioned lot of time for practicing. So maximum time you have to utilize for practicing the questions in all subjects. Okay. Then you will be getting good result there. Nowadays you are getting lot of time compared to last year also. Now lot of time you are getting. So the time maximum you have to utilize. Okay. Our situation and everything will be changing, but you are not supposed to lose your time. Shall we wind up now? Okay, you have to prepare well and come. All the best.